Now we're going to discuss molecular formulas. Molecular formulas are the real-life formulas. They can differ from the empirical formula because the empirical is the simplest. So molecular formulas are real life. However, the simplest are empiricals. So let's take a couple of examples. Water, the real-life formula of water is H2O. And that cannot be reduced, so it is also the simplest formula. So the empirical formula of water is H2O, and the molecular formula of water is H2O. But if you recall, glucose is C6H12O6. That's the real-life formula of glucose. But you could reduce that to CH2O, which is now the empirical formula of glucose. So you see that the empirical formula can be the same as the molecular formula, or it could be different. But no matter what, it's always going to be a multiple. So for water, you would simply have to multiply by 1 because it's the same. However, for glucose, you would have to multiply by 6. So often in a problem, you'll find the empirical formula first, and then they'll tell you how much the molecular formula weighs. So let's suppose that you found the empirical formula to be CH2O, but they said that the actual real-life formula weighs 180 grams. So then what you'd have to do is to find this answer, which you wouldn't know yet, you would add up this and find out that CH2O weighs 30. 12 plus 2 plus 16 weighs 30. And if the real one weighs 180, that's 6 times greater, so then the formula must also be 6 times greater. Hydrates are compounds that have both salt and water that are chemically combined and attached together. Classic example that you might remember is cupric sulfate pentahydrate. So if you were asked to find the percent of water in a hydrate, you would need to know the part over the whole. The part is the water, and the whole is the hydrate. This will also help you in trying to determine the procedure for the lab, that you have to find the percentage of water in a hydrate and the empirical formula. So we need to know how much water is in here and how much the whole hydrate weighs. Well, if I tell you the formula is CuSO4.5H2O, you could find that mass yourself. So what you would do is take Cu, which is 63.5, and S, which is 32.1, and 4 times oxygen, which is 4 times 16. And you're going to add that to all the water, which is 5 times 18, because it's 2 times 1 plus 16. So 5 times 18. That's going to equal the total. So when you add that up all together, 63.5 plus 32.1 plus 64 plus 4 times 16 gives you still going. Sorry, guys. I thought I had paused. I got to do that again. 39.6 plus 4 times, it should be 5 times 18, plus 5 times 18, I'm sorry about that. That equals 249.6. 249.6 is the total. So the whole hydrate weighs 249.6, and the water is 5 times 18. 5 times 18 is going to give you a total of 90. So this is 90 grams of water over 249.6 total times 100 equals 249.6 is 36.1%. So this hydrate is 36.1% water. It's the part over the whole. So in your lab, you need to determine, if I give you a hydrate where you don't know what the formula is, how could you figure out how much water is in this, and how could you figure out how much hydrate is in this, and how would you calculate that? Let's suppose you wanted to find the grams of water in 8.88 gram sample of cupric sulfate pentahydrate. Well, you already know it's 36.1% water. So you could simply say 0.361 of the whole thing, 8.88 grams of hydrate, will give you how much water is in it. So we multiply this out. That's going to give you 3.21 grams of water in this sample. Okay, now let's suppose you want to find the empirical formula of a hydrate from sample data. Let's suppose, and this again will help you with your lab, let's suppose I'm giving you a cupric nitrate hydrate and you don't know the value of N, how many waters go with it. The value of N here was 5, but the value of N here is what you don't know. You need to remember that when I want a formula, we have to go to moles. Formulas are moles. So you have to get moles of salt and moles of water. That's what you're going to need. The moles of salt and the moles of water, and then take a simple ratio. So the hydrate weighs 12 grams, and 9.36 grams of the anhydrous salt remains. So let's remember that a hydrate is always comprised of a salt and water. So the hydrate weighed 12.0 grams. That was the whole thing, 12.0 grams. The anhydrous salt, that's after you heat it up and all the water gets driven off, hint, hint for the lab, 9.36 grams of salt. So we actually have no idea what the water is, but we can easily find it by subtraction. So 12 minus 9.36 equals 2.64 grams. So 2.64 grams is the amount of water. So now we know the salt and the water, but these are in grams and we need to get them into moles. So it's going to be 9.36 grams of CuNO3 2, and we have 2.64 grams of H2O, and we need to convert these into moles. So we're going to use the periodic table with the molar masses, and this is going to be 2.64 divided by 18 is 0.147 moles. And now we need to add up cupric nitrate. So that's going to be 63.5 for the copper. And there are 2 nitrogens altogether, so plus 2 times 14. And then we're going to add 6 oxygens, plus 6 times 16. And that's 187.5. So we're going to convert moles from grams, 187.5 grams. And we divide 9.36 by that number, and we get 0.0499, almost 0.5. Now remember, this is the amount of moles of each one. We need to divide by the smallest to get a simple ratio. The smallest is the 0.0499. So 0.0499, 0.0499, and this of course will be a 1. And when you divide 0.147 by 0.0499, you get pretty much 3. So we know now that the formula is going to be CuNO3 dot 3 H2O. So once again, to get the formula you have to know moles, but in an experiment you would really only know grams. So you have to heat up the hydrate to get the water out, leave the salt behind, find the water by subtraction, change the grams of the salt and the water to moles, divide by the smallest, take a simple ratio, write the formula. And that should help you with your lab procedure. Lastly, the challenge problem. 23 grams of an organic alcohol containing only carbon, hydrogen, and oxygen were burned in air, produced 44 grams of CO2 and 27 grams of water. What is the empirical formula of this alcohol? I'll actually do this on the next video.